Right, so today we're doing section 5.1, rational exponents. This is taking us into our radical functions unit. Some of this will be review, but stuff that we probably need to revisit a little bit. So you can change any exponential function into into a radical function. And all we have to do is remember that you always have a base to an exponent, and that equals your answer. And all you're doing is moving that around to radical form. So whatever your answer is now going in the radical, and you have your root on the outside, and that equals your base. So now the other thing that we need to do is start changing those actually into rational exponents. And what that is you have your base always equals the power over the root. So you've seen this before, this shouldn't be new. And so we're just going to practice some of those really quick. You've got this right here. So for further examples, you need to know your your n value and your b value. So let's practice some of those. If we have just the square root of 9, we usually don't write the 2 there, but it's understood to be a 2. That would be a 3. We're going back the other way. 81 to the 1/4 means the 4th root of 81. Cube root of negative 27. Remember, that means we have 3 numbers that multiply together to multiply to negative 27. But if I write that in radical form, that's 27. This is a power of 1, so it's 27. Negative 27 to the 1/3. If I have the 4th root of x cubed, this is my power, this is my root. If this ever confuses you, remember roots are on the bottom. Think of a plant, roots are in the ground, right? So they're on the bottom side of that. So this would be x to the 3/4. 25 to the 1/3 would be 25 to the 1st. You can put that 1 there if you need to, and the root comes on the outside of the radical. 5th root of negative 3x is going to look like negative 3x, and you need to make sure it's this entire thing, because this all had the root taken from it. So that's going to be 1 to the 1/5. Y minus 5 to the 3/5. So you have to be careful. This entire thing is being raised to that power. So that is what's going to go in the radical. It all needs to be raised to the 3rd power and then have the 5th root taken from it. Okay, so quickly I would like you to go through and see if you can fill in this chart here. Come back and check your answers. And there is one little correction. This should be the 5th root of 32, not the 4th. Okay, so now that you've got your answers filled in there, remember, if you see the pattern of what's going on, you have even roots, meaning that you've got you have an even number within that root, and you're taking roots here. So if your root is less than 0, right here, you're actually going to have no real roots. So if that number is negative. If that number is equal to 0, you're going to have 1 real, and we call it the nth. This should be nth root. And we'll talk about this more. And if it is greater than 0, so non-negative is positive, you're always going to have 2 real roots. Okay? Odd roots are kind of different, because no matter what the number is, you can, whether that number is negative, 0, or positive, you can always take a root of it. So you can take the cube. We're talking odd roots, so let's say the 3rd root of negative 8. Well, we can do that, because negative 2 times negative 2 times negative 2 gives us negative 8. 0, I can clearly take the 3rd root of 0, and I can take the 3rd root of positive 8, right there. So no matter what that value is, I can always take an odd root of it. So, and it will always have 1 real root. Go back up here to when the a value is greater than 0, so positive, and I'm trying to take an even numbered root. I will always have 2 real roots, because 1 is positive and 1 is negative, right? And we'll see that plus minus sign a lot. Okay, let's do some practice down here. So if my n value, starts you off with 1, is 2, and my a value is 64, that would look like the square root of 64, which would equal 8. I'm going to give you some of these to practice. Come back and check your work. Okay, so work these examples through and I'll have the answers for you in a second. Okay, so let's go back and check. So if I'm taking the second root of 64, the square root of 64, that is 8, but it's positive and negative 8. 8 times 8 is 64. Negative 8 times negative 8 is 64. This is what we mean when we say it has two real roots. Okay? Cube root of negative 27 is negative 3. So let's look at this one. If I'm trying to take the fourth root, well, that means that I've got to have, this would be negative 4 times positive 4. This I can get two roots out of. This one I cannot. So if we have a negative base, or we're trying to take an even numbered root, we're not going to have any real solutions. Okay? Let's go down here. So square root of 64. I need to find a number, same number that I can multiply together 6 times, by itself 6 times to get 64. So 8 times 8 is great, but I only have 2 of them. I need 6 of the same number. So if I break 8 down, I've got 2 times 2 times 2. And I have another set of that, 2 times 2 times 2. Now I have 1, 2, 3, 4, 5, 6 2's. So the sixth root of 64 is 2, and I can check that because 2 to the 6 is in fact 64, so that's correct. If I take the fourth root of 16, I need to see what number I can multiply by itself 4 times. So I can do 4 times 4, but that's only 2 of them. I need 4. Well, each one of those 4's breaks down to a 2. And then I'm going to take that to the negative 7. So the fourth root of 16 is 2. I'm going to take that to the negative 7th power, which would give me 1 over 2 to the 7th. Great, let's keep going. Okay, so sometimes you'll see what we call a fractional or a rational exponent. And you'll see both terms, they mean the same thing. It is always easier to take the root of that number first and then raise it to the power. It's the same thing as canceling fractions when you're multiplying. It's usually easier to cancel first and then multiply. So we can rewrite this. Think about what this really is. This is negative 27. And because when we raise a power to a power, it's really 2 times 1/3. So let's take the cube root of negative 27, and then we'll square that. So we know that the cube root of negative 27 is negative 3. And then we're going to square that, so we will get 9. Okay? You could definitely square it first and then take the cube root, but you're going to deal with much bigger numbers, so I just think that's easier. So let's take 1 over 81 to the negative 3/4. We know from our exponent rules that I take this fraction, and I'm going to reciprocate it, so we get 81 to the 3/4. I'm not flipping the fraction, I'm just changing that to a positive. I'm flipping the base. So now I can take the fourth root of 81 and then cube it. So the fourth root of 81 is going to be 3, and then I'm going to cube that, and I get 20. Sorry about that. It's going to be 27. Okay? So let's flip it around. Or actually, we're going to do some now that don't have a nice even root. We've used some really pretty numbers so far, but of course in life they're not all going to be pretty. And we've got to learn how to deal with that. So we are in fact going to do the same thing. We're going to take the fourth root of 187 and then raise it to the 3rd power. Now, the other thing that you can do, if you write this in a fractional form, you would have 187, 3 is your power, and 4 is your root. You can actually raise that to the 3/4 power, or 187, in this case to the 0.75 in your calculator. You can definitely do that. There's a couple ways you can do this. So you can do 187. In this case, we have a y to the x key, to the 0.75. And your calculator is capable of doing that. So, and we can round off to 2 decimal places, that's fine. So, if I were to take the fourth root first and then cube it, you can definitely do that. If you switch it to fractional exponents, though, it's actually easier, because even if you have kind of a funky fraction, you can do 187 y to the x, and all you have to do is put in parentheses, do 3 divided by 4, close your parentheses, and you'll get the same answer. So if you're going to use your second function key, it's actually the same key. If you're going to use it as a root, you're going to use the same key, but you have to do the second function first. So you're going to do 187, second function, that would be the fourth root, and then I'm going to raise that to the 3rd power, and I get the same answer. So there's 2 different ways to do the same problem. You need to be skilled at your And your calculator is going to be different than your neighbor's and different than mine, so you just need to make sure that you know how to use your own calculator. Okay, and a perfect lesson in why you need to know how to use your calculator, because on the other one I was not entering it correctly. So on this one, it gives me better options than it's the calculator I'm used to. So you're just going to put straight in 1 divided by, and I'm going to put parentheses around it, point negative 17, and I'm going to raise that, this is to the 3/5, so I know that's 0.6, and I'm going to get negative 0.183, round it off to. Okay, you can do that in separate steps if you need to. Alright, I'm going to give you some equation practice, because we definitely can solve radical equations, and that's kind of the entire point of this unit. So we'll get them all written down and then we'll work through. Alright, so just take a quick minute and get your problems written down. We'll go through and alright, let's start with example 10. So in order to solve that, remember I'm still solving for x. I need to divide both sides by 2. I get x squared equals 9. In order to get the radical out, I take the square root. The other thing you're really doing is you're raising that to the 1/2 power. And I know when I raise a power to a power, I multiply 2 and 1/2 are going to cancel each other out. And I get x equals plus or minus 3. That's an important thing here. If I want this a minus 10 to just be a minus 10, the easiest thing to do is raise that to the 3/2. And if I raise this to the 3/2, that will, the fractional exponents actually make these problems easier. So 2/3 times 3/2, they cancel each other out, and I just get a minus 10. Here, I can do one of two things. I can cube it and then take the square root. To me, it's easier to take the square root of 4 and then cube it. The square root of 4 is 2 cubed, so I get 8 minus 10 equals 8. And remember that I have plus or minus 2. So I would have plus or minus 8, because negative 2 cubed is negative 8, positive 2 cubed is positive 8. So I need to solve twice. I have a minus 10 equals 8, and a minus 10 equals negative 8. And I add 10, add 10. So my answers would be a equals 10 and a equals 2. You will have two answers for that. Okay? Let's go down here. I'm going to subtract 36 from both sides. So I'll get x to the 6th equals 64, which means I need to find a 6th root of 64. Go back in your memory a minute ago, we already did that. And the 6th root of 64 is plus or minus 2. Okay, so on example 13, I'm going to take the 1/5, raise that to the 1/5 power, or take the 5th root. Either way, actually on this side I'm going to write it as a 1/5. So g plus 10, these are canceling each other out, equals 70 to the 1/5. I can pop that in my calculator, and I would have 70 to the 0.2, because 1/5 is equal to 0.2. And that gives me 2.34. You can round it off to 2 decimal places, that's fine. Subtract 10. So g would equal negative 7.66. Alright, here's a couple for you to try on your own at the bottom. Check them. Do them on your own. Come back, check your work. Alright, and there's your solutions. Taking the 5th root of negative 243, which gives me negative 3, and then raising that to the 3rd power, which gives me negative 27. I really want you guys to get in the habit of canceling out your fractional exponents this way, because it's much easier. So I'm just multiplying by the reciprocal on both sides. I can take the square root of 4. Remember that you have a positive and negative root when that base is positive and the root is even. And then I'm going to cube both of those, so plus or minus 2 cubed gives me plus or minus 8. That's it.